Hello friends, I am Professor Yogesh Chaba from Department of Computer Science and Engineering, Guru Jambeshwar University of Science and Technology, Hisar, Haryana. Today in this lecture, we will study about Wi-Fi technology. First of all, please see the contents which I shall cover. After covering brief introduction about Wi-Fi technology, I shall take up its layered protocol architecture, which will be followed by Wi-Fi standards. In last, I shall cover Wi-Fi frame format. A wireless local area network WLAN is a data communication system implemented as an extension or as an alternative to a wired LAN. Wi-Fi is a technology of wireless local area network based on the IEEE 802.11 series of wireless standards issued by the Institute of Electrical and Electronic Engineers IEEE, an international professional organization for electrical and electronic engineers. The IEEE does not test equipment for compliance with their standards. The non-profit Wi-Fi Alliance was formed in 1999 to establish and enforce standards for interoperability and backward compatibility and to promote wireless local area network technology. The Wi-Fi Alliance enforces the use of the Wi-Fi brand to technologies based on the IEEE 802.11 standard. Manufacturers with membership in the Wi-Fi Alliance whose products are manufactured as per IEEE 802.11 standard gain the right to mark their products with the Wi-Fi logo. Specifically, the certification process requires compliance to the IEEE 802.11 radio standards, the WPA and WPA2 security standards and the EAP authentication standards. Any manufacturer who manufactures product as per these standard can put a Wi-Fi logo on their product. There are several technologies to choose from while selecting a wireless LAN solution, each with advantages and limitations. Most wireless LANs use spread spectrum, a wideband radio frequency technique in which the signal is spread out over the available bandwidth. There are two types of spread spectrum. First is frequency hopping and second direct sequence. Frequency hopping spread spectrum FHSS uses a narrow band carrier that changes frequency in a pattern known only to the transmitter and receiver. On the other hand, direct sequence spread spectrum DSSS generates a redundant bit pattern for each bit to be transmitted and requires more bandwidth for implementation. This bit pattern, called a chip or chipping code, is used by the receiver to recover the original signal. Even if one or more bits in the chip are damaged during transmission, statistical techniques embedded in the radio can recover the original data without the need for retransmission. Now, let us move on to the layered protocol architecture of IEEE 802.11. The IEEE 802.11 standard only covers the physical layer and medium access layer of OSI reference model as shown in figure. The physical layer is subdivided into Physical Layer Convergence Protocol PLCP and the Physical Medium Dependent Sublayer PMD. The PLCP sublayer provides a carrier sense signal called Clear Channel Assessment CCA and provides a common physical service access point SAP independent of the transmission technology. The second sublayer PMD handles modulations and encoding or decoding of signals. The MAC management support medium access control, association and reassociation of a station to an access point and roaming between different access points. It also controls authentication mechanism, encryption, synchronization of a station with regard to an access point and power management to save battery power. Further, 802.11 uses frequency hopping spread spectrum FHSS, direct sequence spread spectrum DSSS, orthogonal frequency division multiplexing OFDM and high rate direct sequence spread spectrum HRDSSS modulation techniques at physical layer. Frequency hopping spread spectrum FHSS uses 79 channels of 1 megahertz each and a pseudo random number generator is used to produce the sequence of frequencies hopped to. This method provides a fair way to allocate spectrum in the unregulated ISM band. Direct sequence spread spectrum DSSS technique support communication speed of 1 or 2 Mbps. It basically uses a technique similar to code division multiple access CDMA. Next modulation technique used in physical layer is orthogonal frequency division multiplexing OFDM, which delivers 54 Mbps and above speed in the wider 5 GHz ISM band. Next technique is HRDSSS, that is high rate data sequence spread spectrum, which offers speed of 11 and 22 Mbps in 2.4 GHz bandwidth. In MAC layer, IEEE 802.11 uses two modes of operations. The first called distributed coordination function DCF and second point coordination function PCF. DCF does not use any kind of central control. It uses a protocol called carrier sense multiple access with collision avoidance CSMA by CA. In this method, both physical channel sensing and virtual channel sensing is done. In physical channel sensing, when a station wants to transmit, it senses the channel. If it is idle, it just starts transmitting. It does not sense the channel while transmitting, but transmits full frame, which may get destroyed at the receiver due to interference. If a collision occurs, the colliding station waits for a random amount of time using the Ethernet binary exponential Beckhoff algorithm and then try again later. In virtual channel sensing scheme, medium access with collision avoidance MACA is used. In point coordination scheme, PCF base station is used to control all activity in its cell. Now, let us see different wireless LAN standard for IEEE 802.11. IEEE 802.11 is a set of medium access control and physical layer specification for implementing wireless local area network in 2.4 and 5 gigahertz frequency band. They are created and maintained by the IEEE LAN Standard Committee IEEE 802.11. The base version of the standard was released in 1997 and had many subsequent amendments. The standard and amendments provide the basis for wireless network products using the Wi-Fi brand. There are several wireless LAN standards, each suited for a particular environment as shown in figure. First standard of IEEE 802.11 series is 802.11 itself, which was released in 1997. It offers 1 to 2 Mbps speed with an indoor range of 20 meters and an outdoor range of 100 meters. It uses FHSS and DSSS as spread spectrum technique. It operates on 2.4 gigahertz ISM band. Next standard is 802.11a, which was released in 1999. It offers 54 and 108 Mbps speed with an indoor range of 35 meters and outdoor range of 120 meters. It uses OFDM as modulation technique. It operates on 5 gigahertz ISM band. Since the 2.4 gigahertz band is heavily used, so using the relatively unused 5 gigahertz band gives 802.11 a significant advantage. In theory, 802.11 a signals are absorbed more readily by walls and other solid objects in their path due to their smaller wavelength, and as a result they cannot penetrate. Now, moving on to IEEE 802.11b. This standard was released in 1999. It offers 11 and 22 Mbps speed with an indoor range of 35 meter and outdoor range of 120 meters. It uses HRDSSS as spread spectrum technique. It operates on 2.4 gigahertz ISM band. Next is IEEE 802.11g standard. This standard was released in 2003. It offers 54 Mbps speed with an indoor range of 38 meters and outdoor range of 140 meters. It uses OFDM and DSSS as spread spectrum technique. It operates on 2.4 gigahertz ISM band. IEEE 802.11n released in 2009 is an amendment that improves upon the previous 802.11 standards by adding multiple input, multiple output MIMO antennas. 802.11n offers speed of 54 Mbps to 600 Mbps using OFDM spread spectrum technique. It operates on both the 2.4 GHz and the lesser used 5 GHz band. Support for 5 GHz band is optional. This standard offers indoor range of 70 meters and outdoor range of 250 meters. IEEE 802.11 AC released in 2013 is built on 802.11 N. It offers speed in the range of 1300 Mbps and operates on 5 GHz ISM band. Other IEEE 802.11 standards, IEEE 802.11d addresses the spread of technology to countries not addressed by IEEE. IEEE 802.11e focuses on the quality of service associated with wireless transmission of multimedia applications. IEEE 802.11f addresses roaming between APs and interoperability between different vendor groups. IEEE 802.11h focuses on frequency selection and power concerns on the 5 GHz band in European countries. IEEE 802.11i focuses on enhancing WLAN security and authentication for 802.11 that include Radius, Kerberos and IEEE 802.1x. IEEE 802.11j focuses on the Japanese equivalent of 802.11h. IEEE 802.11ad is an amendment that defines a new physical layer for 802.11 network to operate in the 60 GHz spectrum. Products implementing the 802.11 AD standard are being brought to market under the WiGig brand name. The certification program is now being developed by the Wi-Fi Alliance instead of WiGig Alliance. The peak transmission rate of 802.11 AD is 7 gigabits per second. IEEE 802.11 AF, also referred to as Wi-Fi or Super Wi-Fi, is an amendment approved in February 2014 that allows WLAN operation in TV white space spectrum in the VHF and UHF bands between 54 and 790 megahertz. It uses cognitive radio technology to transmit on unused TV channels. Wireless LANs use electromagnetic waves to communicate information from one point to another without relying on a wired connection. Radio waves are often referred to as radio carriers because they simply perform the function of delivering energy to a remote receiver. The data being transmitted are superimposed on the radio carrier so that they can be extracted accurately at the receiving end. This process is generally referred to as carrier modulation. IEEE 802.11b and 802.11g standard utilizes the 2.4 GHz spectrum. However, 802.11a use the more heavily regulated 5 GHz band. IEEE 802.11n utilizes both 2.4 GHz and 5 gigahertz band. These bands are commonly referred to as 2.4 gigahertz and 5 gigahertz band in most of the literature. Each spectrum is subdivided into channels with a center frequency and bandwidth analog to the way radio and TV broadcast bands are subdivided. The 2.4 gigahertz band is divided into 14 channels spaced 5 megahertz apart, beginning with channel 1, which is centered on 2.412 gigahertz. The latter channels have additional restrictions or are unavailable for use in some regulatory domains. Figure shows exact frequencies of 14 different channels used in 2.4 gigahertz ISM band. Now, we will move on to the frame format of IEEE 802.11 standard. Frame format of this wireless LAN standard is as shown in figure. There are 9 fields in frame format of this standard, starting from frame control to checksum. Frame control field has 11 subfields. Now, let us see each field one by one. Frame control field, which is of 2 bytes, is used for control purpose. Details of subfield of frame control field will be discussed after discussing main fields. Second field is duration, which tells how long the frame and its acknowledgement will occupy the channel. The frame header contains 4 addresses. The source and the destination are obviously needed, and the other 2 are used for the source and destination base stations for inter-cell traffic. The sequence field allows fragments to be numbered. Of the 16 bits available, 12 identify the frame and 4 identify the fragment. The data field contains the payload up to 2312 bytes, followed by the usual checksum of 4 bytes. Now, let us see details of frame control field, which has 11 subfields. The first of these is protocol version, which allows 2 versions of the protocols to operate at the same time in the same cell. Then comes the type field, which indicates data, control or management type of frame, and next field indicates subtype. The 2DS and from DS bits indicates that the frame is going to or coming from the inter-cell distribution system, for example, Ethernet system. The MF bit means that more fragments will follow. The retry bit marks a retransmission of a frame sent earlier. The power management PWR bit is used by the base station to put the receiver into sleep state or take it out of sleep state. The more bit indicates that the sender has additional frames for the receiver. The W bit specifies that the frame body has been encrypted using the WEP wired equivalent privacy algorithm. And finally, the O bit tells the receiver that a sequence of frame with this bit on must be processed strictly in order. So, dear friends, today in this lecture we have covered introductory concepts of Wi-Fi technology, followed by its layered protocol architecture and IEEE 802.11 standards. In last, we have seen frame format of IEEE 802.11 technology. So, this was all about Wi-Fi technology. Thank you.